Greetings. In this video, I want to deal with the roots of a quadratic equation, and this particular question is fairly routine and appears regularly on examination papers. And the question is to find the range of values of k such that the quadratic equation x squared plus 2 bracket 1 minus kx plus 3 minus k equals 0 has roots which are both positive and also real. Just a reminder, if you get a quadratic equation like x squared plus bx plus q equals 0, then the sum of the roots is minus b, and the product of the roots is q. Now, in our equation, both roots are to be positive and real, then their sum must be real, and their product, sum must be positive, and their product must also be positive. So I'll repeat that. If in our equation both roots are positive and real, then their sum and product are both positive. So we will have 2 times 1 minus k is less than 0, and 3 minus k is greater than 0, from which we have 1 minus k is less than 0, which means k is greater than 1, and also 3 is greater than k. So k has to lie in the range between k is greater than 1 and less than 3. But there's also another condition, and that the roots have to be real. So this means that the discriminant of the original equation has to be equal to or greater than 0. So that means that 2 times 1 minus k all squared minus 4 times 1 times 3 minus k has to be equal to or greater than 0. That's the discriminant. So simplifying all that, we'll have 4 times 1 minus 2k plus k squared minus 4 times 3 minus k. It's got to be equal to or greater than 0. Multiplying all that out, we get 1 minus 2k plus k squared minus 3 plus k equal to or greater than 0. The 4's having been cancelled away, and that comes down to the quadratic equation k squared minus k minus 2 equal to or greater than 0. And factorizing the left-hand side, it's k minus 2 times k plus 1 has to be equal to or greater than 0. So if you draw a little graph there of the function k minus 2 times k plus 1, that's what it looks like. And it cuts the x-axis at minus 1 and 2. So k has to be equal to or less than minus 1, and k also has to be equal to or greater than 2. Okay, so our range is narrowed down to k being equal to or greater than 2 and less than 3. And that does it. Thanks very much for listening.